Friends, last class, last part, what we understood? Magnetic force on a current carrying conductor in a uniform magnetic field. What is the expression standard one? Fm is equal to magnetic force acting on current carrying conductor is equal to what? Bil sin theta, Bil sin theta, or else I into L bar cross V bar. Also we understood what Lorentz force. Okay, what is the Lorentz force? Sum of the electric and magnetic force. Means total force experienced by charged particle in electric and magnetic field is called as what? Lorentz force. And force experienced by charged particle in uniform magnetic field. Magnetic force experienced by charged particle in a uniform magnetic field. Okay, what is that? F bar is equal to Q into V bar cross V bar. Okay, na? So this is what magnetic force experienced by charged particle in a uniform magnetic field. This also we understood. That is a magnetic of force is equal to QVB sin theta. QVB sin theta. Where Q is what? Magnitude of charge of the particle or charge of the particle. V is what? Magnitude of velocity of the particle. B is what? Magnitude of magnetic field induction. Theta is what? Angle between velocity of the charged particle and magnetic field. If theta changes, the path of the particle also changes and we will observe the different motion. Then today our class is what? Motion of charged particle in a magnetic field. So today in detailed manner we are going to understand motion of charged particle in a magnetic field. Okay. Then motion of charged particle in a magnetic field. First already we understood this force formula in last parts. Right? So what is the magnetic force experienced by charged particle in uniform magnetic field? What is the formula, students? QVB sin theta. Okay, na? What is the theta here? Theta is the angle between the velocity of charged particle and the magnetic field. Correct? So for this entire thing, we are assuming. Okay, one important assumption here. What is that? Magnetic field should be uniform. Okay, magnetic field should be uniform. Means magnetic field ends are parallel to each other. Then a magnetic field, we can say magnetic field is what? Uniform. Here three cases are there. These three cases are very important for board examination point of view and competitive examination point of view. These three cases. Okay, so case 1, theta is equal to 0 degree. So theta is equal to 0 degree means what is the theta here? Angle between velocity of charged particle and magnetic field. That is equal to 0 degree. Okay, so this is the case. Angle between velocity of charged particle and magnetic field. Okay, this positive charged particle, how it is moving? Parallel to the magnetic field. Correct, na? So magnetic field is, all these magnetic fields are what? Parallel to each other. Okay, then equal distance. That means it is a uniform. Magnetic field should be what here? Uniform. Which axis magnetic field is acting along which axis? Along the positive x-axis. Then charged particle is moving along which axis? Along the positive x-axis. Means velocity of the charged particle and magnetic field both are parallel to each other. When angle now velocity of the charged particle is moving what? Parallel to the magnetic field. In this case, what is the theta? Theta is equal to 0 degree. What is the theta? Angle between velocity of the charged particle and magnetic field. How much it is? 0 degree. Okay. So in this case, if theta is equal to 0 degree, right? If substitute theta is equal to 0 here. Sin 0 how much? 0. Then magnetic force how much? 0. Correct, na? So then if theta is equal to 0 degree means angle between velocity of charged particle and magnetic field is 0. Then so magnetic force acting on charged particle is what? 0. Means there is no force acting on the charged particle. There is no magnetic force acting on the charged particle. So in that case, there is no force. Suppose in a first year in kinematics already understood what if there is no force, the particle is moving along a straight line, if there is no force acting on it, okay, what is the path of the particle? So the path of the particle is what? Straight line. Means there is an undeflected path. The path is undeflected, not deflected. Means it is moving along what? Straight line path. This motion is called as what? Linear motion. Which motion, students? Linear motion. Okay. So here positive charge is in which motion? Linear motion. If angle between the velocity of charged particle and magnetic field is 0, okay, na? Then what is the force acting on the charged particle? What is the magnetic force acting on charged particle? 0. Okay. Then what is the path of the particle? Okay, there is no force. No force, nothing but which direction the particle is moving? In the direction the particle can be moved. If any force acts means the path can be changes. Okay. There is no force acting on it. Correct na? So there is no magnetic force acting on it. Then the charged particle how can move? So which direction the particle coming? In that same direction the particle can be moved. Nothing but, so it is moving parallel to the magnetic field means along the direction of magnetic field the charged particle can be moved. Okay, such a motion is called as what here? Linear motion. If theta is equal to 0 degree, okay, angle between velocity of charged particle magnetic field is 0 degree, then the path of the particle is what? A straight line. Very important. Okay, if angle between the velocity of charged particle magnetic field is angle between the velocity of charged particle magnetic field is 0 or 180. 180 means if instead of the charged particle moving along the this direction, the charged particle is moving opposite direction of the magnetic field. Suppose in this direction. Okay, so in this case also, in this suppose instead of moving this direction, the charged particle is moving along the negative x-axis. Magnetic field is acting along the positive x-axis. The charged particle is moving along the negative x-axis. In that case, what happened? This charged particle is moving anti-parallel to the magnetic field. Or else, what is the angle between this velocity of charged particle and magnetic field? 180 degree. How much? 180 degree. Correct na? Okay. So in this case, theta is equal to 0 degree. In this case, what happened? Theta 180 degree. If theta is equal to 0 degree or theta is equal to 180 degree. If angle between velocity of charged particle and magnetic field 0 degree or 180 degree, then what is the force experienced by charged particle in uniform magnetic field? 0. Why? Because sin 0 0, sin 180 also 0. Then magnetic force experienced by charged particle in uniform magnetic field, how much, students? 0. In that case, what is the path of the particle? Path is what? Linear, a straight line. Okay. And what is that motion? Such motion is called a linear motion. Very important in a competitive examination point of view, board examination point of view. Okay. Come to the case 2. Case 2. If angle between the velocity of charged particle and magnetic field is 90 degree, means how the charged particle is moving here? The charged particle is moving perpendicular to the magnetic field. Okay na? So if theta is equal to 90, then sin 90 how much? Sin 90 is 1. Sin 90 is equal to 1. Then there is a maximum force experienced by charged particle in that case. Okay, that is what? QVB. So maximum force experienced by charged particle in uniform magnetic field when it is moving perpendicular to the magnetic field. In that case, what happened? QVB. Q is what? Charge of the particle. So V is a magnitude of velocity of charged particle. B is a magnitude of magnetic field induction. So in this case, what is the path? Okay, what is the path of the charged particle? Okay, circular path. How it is? Okay, now we will discuss that. Okay, how this path of the particle is circular. Let us consider. Okay, this Q charged particle is moving what? Perpendicular. So in this case, this into mark represent what? Magnetic field is perpendicular into the board. Magnetic field is perpendicular into the board. These are the magnetic field lines. How the magnetic field lines? Perpendicular and into the board. Now, so in this magnetic field lines, the charged particle entering what? Perpendicular to the magnetic field. The charged particle is, okay, suppose it is moving along the x-axis, magnetic field is along what? Negative z-axis. Okay, so this fingers representation is what? Perpendicular into the board. This cross representation is what? So magnetic field is perpendicular into the board. Now charged particle is how it is entering? Perpendicular to the magnetic field. Then on which direction force experience, on which direction the force acts on the charged particle? Okay, so by using which rule we can determine? Okay, by using right hand rule. Understand what is the right hand rule? Okay, stretch your palm along the direction of velocity of the charged particle. Okay, now which direction magnetic field is there? Okay, so towards the board. Okay, towards the board. Okay, curl your fingers. Then which direction force acting here? Along the, okay, so y-axis. Along the y-axis. At this point, which direction the force acting here? So along the y-axis. Now this is a magnetic force experienced by charged particle at that point. I will say, okay, you know the Fleming left hand rule, correct na? So what is the Fleming left hand rule? Stretch first 3 fingers of the left hand mutually perpendicular to each other. Now this 4 finger represent what? Magnetic field. Okay, magnetic field how it will be? Perpendicular into the board. Now the central finger represent what? Direction of current, direction of motion of the charged particle. Now, so this is a which direction you open thumb finger? That is what? Direction of force acting on the charged particle. Alright, the charged particle tries to move in the straight line. The charged particle is how it is entering? Okay, straight line. Okay, and perpendicular to the magnetic field. But so this due to this magnetic field, the force experienced by the charged particle in which direction? Okay, y-axis here. Means perpendicular to this velocity and magnetic field, this force acting. Okay, due to that what happen? The path is not a straight line. Little bit curved path it will come. Okay, one more instant I take it. At this instant you can check it. Okay, at this instant what is the direction of velocity? The charged particles tries to move in this direction. But what happen? Magnetic field is what? Perpendicular into the board. Magnetic field is what? Perpendicular into the board. Now, direction of positive charge. This is what direction of current. Direction of positive charge. Okay, na? Now, which direction thumb is opened? Which direction thumb is opened? Okay, towards the center. Okay, na? Right, towards the center. Now, this is a direction of, okay, at this point, this is the direction of magnetic force. Again, at this point, sir, due to this one, so magnetic force, at this point, magnetic force acting in this direction, but the charged particle is moving which direction? Perpendicular to magnetic field. So, due to that, okay, the particle again come in the, okay, curved path. Again, at this point, what will happen? Check it. What is the direction? Which direction the particle can be moved? Okay, apply Fleming left hand rule. Okay, at this instant. Now, so forefinger represent direction of magnetic field, right? So central finger represent direction of current. Correct, na? That is the direction of positive charge along the velocity direction. Now, which direction thumb is opened? Downward. Okay, right. So at this point, what is the direction of a force? Okay, this is. Next, at this instant you have to check. Okay, at this instant what is the direction of force? Same thing. Okay, due to this magnetic force, actually the particle tries to move in a straight line, but magnetic force acting towards center, due to that the particle come in the curved path. Again, one more instant I taken here. Okay, now, so magnetic field is perpendicular to the ball. Fleming left hand rule, correct na? So forefinger, central finger and thumb finger. Okay, so stretch your forefinger and central finger. Forefinger is okay, along the direction of magnetic field. Magnetic field, how it will be? Perpendicular into the border. And so what is it? This is a direction of motion of charged particle. Direction of motion of charged particle. This thumb is what? Direction of force acting on the charged particle. Okay, which direction acting? Okay, towards the center. Means each and every point, the magnetic force is acting which direction? Towards center. So each and every point you can apply the rule. Which rule? Fleming left hand rule or so right hand thumb rule. Okay, then you will get the direction of what? Magnetic force. What is how to apply the right hand thumb rule? Easy, very easy right hand thumb rule also. Stretch your palm along the direction of velocity, the positive charge. Okay, na? Now curl your fingers towards the magnetic field. Correct? It is the direction of force. Okay, at this point what happened? So again, curl your, okay, stretch your palm along the direction of velocity, positive charge particle. Okay, magnetic field is what? Perpendicular into the board. Okay, curl your fingers. Which direction open? That is the direction of, okay, magnetic force acting on the charged particle. Okay, here also same thing. Right, so it is a direction of velocity of the charged particle. Magnetic field is this one. Okay, towards the border, means curl your fingers towards the magnetic field. This is about direction of force acting on the charged particle. Okay, here, so this is a palm. Okay, stretch your four fingers. Okay, of your palm, what happened? Stretch four fingers along the direction of positive charge. And curl your fingers towards the magnetic field. This is the direction of what? Okay, this thumb finger, which direction thumb is opened, that is the direction of magnetic force acting on the charged particle. Means each and every point, how that force is acting along the radius towards center. Okay, along the radius towards center. Means, okay, like this, continuously, the particle is doing in which path the particle is moving here? Circular path. This motion is called which motion? Circular motion. In this case, the charged particle is moving along which path? Circular path. Means, if the charged particle is entering, the charged particle is moving perpendicular to the magnetic field. Okay, now this is a magnetic field, this is charged particle entering. Okay, magnetic field is what? Perpendicular into the border. That now charged particle is entering what? Perpendicular to the magnetic field. It is suppose x-axis, it is negative z-axis. What is the angle between x-axis and negative z-axis? 90 degree. Okay, if the angle between velocity of charged particle and magnetic field is 90 degree. Okay, so which path the particle is going? Circular path. Why? Magnetic force acting which one here? Okay, this magnetic force is making which one? Circular path. Okay, so this magnetic force is what? Along the radius towards center acting. This force is a centripetal force. Okay, now that's why the particle is moving along the circular path. This motion is called as here. In this case, what happened? The charged particle is in a circular motion. Okay, na? Right? If the angle between the velocity of charged particle and magnetic field is 90 degree. Okay, force experienced by charged particle in that field is what? Maximum, that is QVB. And what about path? Path is what? Circle. Okay, how we understood? Next, if theta is other than 0 degree, 90 degree, 180 degree. Not 0 degree, not 90 degree, not 180 degree. In that case, what is the force experienced by charged particle in the uniform magnetic field? What is that? Q V B sine theta. Okay, in this case, what happens? Magnetic field is acting along the x-axis. Okay, so magnetic field ends are parallel to each other and equal distance means this is which magnetic field? Uniform magnetic field. Correct, na? Right. Now, the charged particle, how it is entering? Not along the direction of magnetic field. In this case, the charged particle is moving along the direction of magnetic field or opposite direction of magnetic field in this case. But in this case, the charged particle is not moving along the direction of magnetic field. Okay, not moving opposite direction of magnetic field in this case. Okay, and also not moving perpendicular direction of magnetic field. These are the magnetic field ends. The charged particle is moving like this. Means the angle between the velocity of charged particle and magnetic field, how much it is? Theta. That theta is not 0 degree. Correct, na? This theta is not 0 degree, not 90 degree, not 180 degree. If theta is not 0 degree, not 90 degree, not 180 degree. Correct, na? So this velocity is in which one? 2-dimensional. The velocity of charged particle in which one? 2-dimensional. Okay, like xy plane. Suppose along x-axis magnetic field is there. Okay, so this is y-axis. Now this angle between the velocity of charged particle and magnetic field, how much here? Theta. This velocity get what? Two components. One is horizontal component, another one is what? Vertical component. So what is the horizontal component here? Horizontal component is what here? V cos theta. This is what? V cos theta. So this is what? V sin theta. V sin theta. Okay, in kinematics already understood horizontal component and vertical component. Correct, na? The velocity of the charged particle, initial velocity of the charged particle is this one. This in this direction the charged particle is moving. This is a magnetic field. Angle between velocity of charged particle and magnetic field is theta, means along the magnetic field velocity component is V cos theta. Along the magnetic field velocity component is what? V cos theta. Correct, na? Cos theta is equal to adjacent by hypotenuse. Correct, na? Adjacent is what? V cos theta. Vertical component is what? Okay, so perpendicular to this magnetic field. Okay, what is the velocity component here? V sin theta. V cos theta along the magnetic field, V sin theta along the perpendicular to the magnetic field. Okay, this V cos theta is acting what? Along the magnetic field, means this component is makes the charged particle move along the straight line. This V sin theta is makes what? Okay, perpendicular to the magnetic field. If the velocity of charged particle perpendicular to the magnetic field, means the path of the particle is what? Circle. Right? This component is makes what? Charged particle is moving along the direction of magnetic field. This component is makes what? The particle is moving along the circular path. Right? This combination of what? Straight line and circular. Straight line, circle. Straight line, circle. Then that path is called a helical. The path is what? Helical. Okay. Otherwise, you can apply Fleming left and easily can understand what? So the which direction the particle can be moved. Due to okay V cos theta, the particles wants to move in which direction? Okay, along the direction of magnetic field. But this V sin theta is what? Perpendicular to the magnetic field. Okay, if the particle is moving perpendicular to magnetic field, but this some velocity component is what? Perpendicular to the magnetic field. Okay, so magnetic field is this forefinger along the direction of magnetic field. Correct, na? So this V sin theta component, this is a V sin theta component. This is a V sin theta component. Okay, and this thumb finger is what? Okay, direction of magnetic force. Direction of magnetic force is like this at this point, like this. Okay, so like this, 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 like this. Okay, how it will move? So the path can be helical, helix path. Okay, so such motion is called as what? Helical motion. Okay, nothing but if angle between velocity of charged particle magnetic field is other than 0 degree or 90 or 180. Okay, other than 0 degree or 90 degree or 180 degree. Okay, then certain angle not equal to 0, not equal to 90, not equal to 180, some angle is there, nothing but in that case that is a combination of what? Straight line and circular, that is called as what? Helical motion. Which motion? Helical motion. So very very important, these three cases in the competitive examination point of view or board examination point of view, very very important. Once again tell me, if the angle between velocity of charged particle magnetic field is 0 or 180 degree, or if the charged particle is moving parallel to the magnetic field or anti-parallel to the magnetic field, what is the force experienced by charged particle, students? 0. Then in that case, what is the path of the particle? Straight line. Okay, such motion is which motion? Linear motion. In that case, what is the motion of the charged particle? Linear motion. Next, case 2. Theta is equal to 90 degree. Theta is equal to 90 degree is nothing but so angle between velocity of charged particle and magnetic field is what? 90 degree. Okay, or else the charged particle is moving perpendicular to the magnetic field. Okay, cross represent what here? So the magnetic field is perpendicular into the pole. Correct na? Right. So if the angle between velocity of charged particle and magnetic field is 90 or the charged particle is moving perpendicular to the magnetic field, in that case that is a force experienced by charged particle is maximum, that is QVB. And what is the path of the particle? Path of the particle is what? Circle. Path of the particle is what? Circle. Correct na? Right. So next in this case this positive charge in which motion? Circular motion. Which motion? Circular motion. Case 3. If theta is other than 0 degree, 90 degree and 180 degree, okay, so some 30 degree or 60 degree, okay, or 120 degree, so other than 0 degree, 90 degree, 180 degree means in that case what is the force experienced by charged particle in the in that magnetic field? QVB sin theta. In that so what is the path of the particle? What is the trajectory of the particle, or what is the path of the particle? That is called a helical. Path is helix or helical path. Such motion is what? Helical motion. Why? Here velocity has two components, v cos and v sin theta. Here having only one component, right? It is perpendicular to magnetic field. But here two components. One is one component is along the direction of magnetic field. One component is along it is perpendicular to the magnetic field. Okay, I hope you understood, students, right? Okay, students, right, case 1 we understood, case 2, case in detail manner we are going to discuss now. Case 2, angle between velocity of charged particle and magnetic field is 90 degree means the maximum force experienced, how much it is? QVB. In that case, what is the path of the particle? Circular. What is the path of the particle? Circular. If the particle is moving along the circular path means which force is acting there? Centripetal force. Okay, it is moving with velocity v, right? So the magnetic force acting which direction? Right, so along the radius towards the center. In this case, centripetal force or magnetic force is equal to what? Centripetal force. Understand? The particle is moving along the circular path. Means there is compulsory. Which force is necessary to make the object along the circular path? Centripetal force. That centripetal force is which force here? That force created by whom? Due to the magnetic field, external magnetic field. That force is what? A magnetic force. Magnetic force is so here balanced by what? Centripetal force is balanced by what? Magnetic force. So here magnetic force. So theta is equal to 90. What is the magnetic force here? QVB. Understand? So QVB. Maximum force is QVB. Centripetal force formula already understood first year. What is centripetal force formula? mv square by r. Centripetal force formula is what? mv square by r. So this is a velocity. This is also velocity. Okay. This is magnet of velocity. This is also magnet of velocity. Cancel it. Okay, from this you will get what? R is equal to mv by qb or bq. This is a most important expression. This is a radius of the charged particle. When the charged particle is moving perpendicular to the magnetic field, this is the radius of the charged particle in uniform magnetic field, mv by qb. So this for a given particle in a given magnetic field, this radius of the charged particle, radius of the circle. Okay, the charged particle is moving in the uniform magnetic field perpendicular to it. Then so that radius of the circle is depends upon which one? The speed of the particle. Speed of the particle is more, radius is more. In this case, the radius is proportional to what? Speed of the particle. Speed is more, radius of the particle is more. Means that it can be in bigger size. Radius is more, where speed is more, nothing but in a bigger circle it can be more. If the speed is less, nothing but it can move in the lesser circle, not bigger circle, less radius of the circle it can be selected. Okay, now next step. Then expression for time period, frequency and angular frequency. Right? What is the expression for time period, frequency and angular frequency? First we are going to discuss time period. If the particle is moving along a circular path, okay, time period denoted by symbol what? T. T is equal to, so speed is equal to distance by time, time is equal to what? Distance by speed. Speed is equal to distance by time, time is equal to distance by speed. Okay, so distance how much students here? 2 pi r. along the circular path, total distance covered by the particle in one complete revolution. How much it is? 2 pi r. What is the time period? Time taken for one complete revolution is called as a time period. For complete revolution, how much distance traversed it is? 2 pi r. 2 pi r by speed of the particle. Speed of the particle how much here? V. Distance by speed gives that time period. Right here? So time taken for one complete revolution is called as time period. For complete time period, how much distance it is? Taken 2 pi r. So with what speed? V speed. 2 pi r by V. So T is equal to 2 pi r by V. Correct now? So this is a time period for a revolution of the particle in a uniform magnetic field. If you substitute R here, so what will get? 2 pi by V into mv by bq. What will get? V get cancelled. So then time period is equal to how much will get? 2 pi m by bq. This is also important. So this time period in for given particle and so given magnetic field, this time period does not depend upon speed of the particle. Very important. Time period, the charged particle moving in uniform magnetic field, time period of the charged particle in a uniform magnetic field, when it is moving perpendicular magnetic field, does not depend upon speed of the particle. It is depends upon what here? So mass, given charged particle mass, B, given magnetic field, given charged particle. Okay, na? It does not depend upon it is the time period of the charged particle in uniform magnetic field does not depend upon the speed of the particle. That is very important. Next, what is frequency? So what is the frequency? Reciprocal of time period is called as a frequency. Reciprocal of time period is called as a frequency. That is what? BQ by 2 pi. Reciprocal of this one 2. T is 2 pi m by BQ. Then reciprocal of time period is nothing but BQ by 2 pi m. Next, what? Angular frequency. Angular frequency denoted by symbol is what? Omega. Angular frequency denoted by symbol is what? Omega. That omega, how we can write omega? Omega can be written as 2 pi into, correct na? 2 pi into frequency. Omega can be written as what? 2 pi into frequency. So in first year already understood, angular frequency is what? 2 pi by t, correct na? 2 pi. So how many number of revolution made in unit time is called as what? Angular frequency. How many number of revolution made in unit time is called as a suppose within one revolution, how many radian? 2 pi radian by time period. 1 by time period is called as frequency. So angular frequency nothing but 2 pi into frequency of the charged particle in a magnetic field. Then how much it is? 2 pi into, so frequency how much here? So BQ by 2 pi m. BQ by 2 pi m. So 2 pi get cancelled. You will get angular frequency here, omega. So omega is equal to how much here? BQ by m. I hope you understood. Time period, frequency, angular frequency. Time period how much here? 2 pi m by BQ. How we got? 2 pi r by v. Distance by speed. Particle is moving around the circular path. What is the distance? 2 pi r by speed of the particle. That is equal to 2 pi by v into, what is the radius of the charged particle here? mv by bq. How we got this one? When the charged particle is moving along the along the circular path, which force is necessary to move the charged particle along the circular path? Centripetal force. Here centripetal force is which force? Magnetic force. Magnetic force is how much here? QVB. Why? The charged particle is moving perpendicular to the magnetic field. QVB is equal to centripetal force here, mv square by r. That is equal to r is equal to mv by bq. So here the radius traversed by charged particle in uniform magnetic field depends upon what? Speed of the charged particle in given mass, for given mass and given charge and given magnetic field. Correct na? So speed is more, radius of the circle more. Speed is less, radius of the circle is less. Correct now? Right. Next, time period. So what is the time period? Distance by speed. The particle is moving along the circular path. For that, time taken for one complete revolution is called as time period. That is 2 pi r by v. Then 2 pi by v into r is how much here? mv by bq substituted. Then simplified 2 pi m by bq. This is a time period. Time taken for one complete revolution. In uniform magnetic field is what? 2 pi m by bq. M is what? Mass. B is magnetic field. Q is what? The charge of the particle. This is the time period of the charged particle in uniform magnetic field. And the frequency of charged particle, reciprocal of time period is called as frequency. That is how much? So reciprocal of time period. Reverse this one. bq by 2 pi m. Next, angular frequency is what? So 2 pi multiplied by frequency is called as angular frequency. 2 pi into what is the frequency? Frequency BQ by 2 pi m. 2 pi into BQ by 2 pi m. Okay, simplify 2 pi get cancel. You'll get what omega is equal to b q by m. Omega is nothing but angular frequency. So this is very, again we are going to discuss in the cyclotron.